Aloha and welcome. In this module, we're going to be talking about supporting processors and upgrading memory. And this is going to be for part one. If you're looking at taking the CompTIA A+, it's in the Core 1 220-1101 and the module objectives. So by the end of this module, you should be able to compare the characteristics and features of processes used for personal computers, select, install, and upgrade a processor, compare the different kinds of physical memory and how they work, and upgrade your memory. So let's get into the types and characteristics of processors. The processor is installed on a motherboard and determines the system computing power. Like I said in earlier videos, this is the main thing I consider when I'm putting together a computer. I start with the CPU and I find the motherboard that goes with it, and everything goes from there, your memory and things like that. So we have two major processor manufacturers, that's Intel and AMD. This has been the way it has been for as long as I can remember, and that is quite a ways back. Intel has always been there. AMD was a later actor on the stage, but they're both very powerful alternatives. The features affecting processor performance and compatibility with motherboards include processor speed, lithography, socket and chipsets the processor can use, multi-processing abilities, multi-processing, multi-threading, multi-core processing, and dual processors. Features affecting the processor performance and compatibility with motherboards continued. We have memory cache, memory features on the motherboard that the processor can support for virtualization, which is a big thing if you're wanting to run a lot of different VMs on your system, or Docker and things like that. So support for virtualization is important. Also, if you're a gamer, overclocking is also a big thing. But again, overclocking is not recommended. It shortens the life of your system, and it can cause bizarre behavior in certain situations. So keep that in mind. Yeah, overclocking, bad. But a lot of gamers do it because every frame you can get is worthwhile. So anyways, let's continue on. Today's processor architectures fall into the following two categories. There's hybrid processors known as the x86-64 processors, and the 64-bit processors known as the x64 processors, or IA64. So motherboard form factors. If you look at this one, you'll see that we have two different slots for putting in CPUs. This is the Intel server board S2600 ST, has two Xeon processor sockets and 16 slots for DDR4 memory. So this is quite a honking server motherboard here, made for really good performance. If we look at the Intel processors, the current family processors for desktops and laptops include the following: Intel Core processors, which include the following: Core X series. Those are made for the high-end desktops with graphics. They've got the i9 and the Core i7 that are made for high-end desktops and laptops. I've got an i9 in my system. I also own the i7 and i5 and others as well. So the i5 is well suited for mainstream desktops and laptops, things that you're not really going to be, pushing the envelope in terms of processing. Then you've got the Core i3, which is an entry-level processor for desktops and laptops. Think, grandma, people that are mostly using browsers and things like that. It's not going to be for heavy processing. You can run Excel and things like that. You're not going to have trouble. But if you're trying to multitask and have 100 tabs open in Chrome and things like that, you're going to see some performance issues. But the i3 is really, it's good for a lot of people out there. I always go for the higher end because I do a lot of programming. I like to have the ability to do graphics. I do underwater photography, and that's something that I kind of want to be able to do. I need to be able to do my editing. So I go for the higher end. I usually go for the Core i9, i7. Those are really the sweet spot in terms of price and performance. So Pentium processors are designed for entry-level desktops and laptops. The Atom processors are made for low-end desktops, notebooks, and laptops. And then you've got the Celeron processors that are made for the low-end netbooks and the laptops. I actually have a small, tiny box that has an Atom processor in it, and they really do mean it's made for the low-end desktops. It's not terribly powerful, but if you have like a single-purpose type thing that you do just one thing and you want to do it, pretty well, the Atom processor for that works fine. I actually took out the Windows operating system and put Ubuntu Linux on it, and it runs great. So yeah, just know that you've got different types of processors. They're really aimed at different markets in terms of what you're going to be doing with that computer. Then we've got the AMD processors, and they make a very respectable competitor for Intel. And the processors by AMD are popular in the game and hobbyist markets. They're generally less expensive than the comparable Intel processors. They've always had that reputation. They're the competitor, the underdog. They like to go for lower price, and they're really getting good as far as the performance goes. The current AMD processor family includes, and if you're a gamer, you'll recognize most of these. For desktops, you've got the Ryzen Threadripper, the Athlon with graphics, Ryzen Pro, and Athlon Pro. And some of these have been around for a long time. The Ryzen's been around for a while, but the Athlons have gone back for quite some time, over a decade, maybe even two. For laptops, you've got the Ryzen, the Athlon, the Chromebook, and for servers, you've got the Epic, and that can have up to 64 cores. So think really high end. Then we have the ARM processors. So the ARM stands for Advanced RISC Machine. It's a processing architecture designed to simplify the instruction set that's used for the computing. ARM processors are low cost, they're low power, and they have low heat processors used in mobile devices. So when you don't have a lot of space for cooling and everything else, the ARM processors are very good. Companies that use ARM processors include Samsung, Intel, NVIDIA, Qualcomm, and Apple, just to name a couple. Then when you're selecting and installing a processor, a hardware technician is sometimes called on to do the following tasks: assemble a computer from parts, exchange a faulty processor, add a processor, or update an existing processor. More likely on this list, what I've had to do is exchange a faulty processor on occasion. It's relatively rare, but if you're working on like, let's say you've got an office that you're responsible that has over 100 systems, it will happen eventually. I've worked in smaller offices with 3 or 4 people, and it's a rarity. But as you add the number of systems you're working on, the chances of actually needing to do this does rise. So assembling a computer from parts, in the old days, this is what I did. This was my bread and butter. I would take, and I think I explained this earlier, I would take this magazine called Computer Shopper, look up all the parts that I needed, make sure they were compatible with each other. I'd send it out to, I was working at UH at the Institute for Astronomy at the time. We'd send it out for, we'd have to send out for bids on the things. We'd get back the price quotes, and then we would buy from those vendors, and we'd then assemble it, put it all together, and that was the way we did it. On my own, what I've done is I would always come up with a spreadsheet. In my spreadsheet, I'd list all my parts. I'd have my processor, motherboard, my graphics card. Back in the old days, graphics cards weren't as big a deal as they are now. But I would list out all my things, my network card, if I wanted a network card on it. Now, some of the trends are, a lot of things they come on board, so you don't have to worry about adding in a lot of things like your network card. Some, motherboards have video that's good enough for what you want to do, so that's, absolutely great. So you don't have the need like you did in the old days to, order so many separate parts. A lot of that's, baked into the motherboard itself, which is great. But I'd make out that list and everything. And the processor was the thing that drove that. I would look at it, what do I need in terms of performance? What do I want? And then I'd build the rest of the system around that. So assembling it from parts, that's one thing that, that's one of the cases you're going to see. And also exchanging a faulty processor. On rare occasions, you'll add a processor to the system. Most often when people buy a system that has the ability to, run 2 processors on it or more, they're going to have them already populated on the motherboard. So that's less of a thing you'll be doing. Upgrading an existing processor, yes, you can do that if you want to boost performance just a little bit, but I don't think that happens as much because, bumping, that's something you do often when you first buy it. Buy what you need. If you're going to go out and spend the money plus a little more later on, or let's say it's 4 or 5 years later, I guess you could say maybe the price of that more expensive one got a lot cheaper and it would made sense to do it. But honestly, the economics work out. Just buy it to begin with. But anyway, these are the possibilities. In each situation, it's going to be necessary to know how to match a processor to the system. You always need to know how to install a processor on the motherboard. That goes without saying. And first requirement is to select a processor that the motherboard is designed to support. Or if you do it like I do, you buy the motherboard that's required for the CPU. But if you're coming into a situation where they already have a motherboard, yes, you need to figure out what is supported, and you can always go to the documentation on that. Google it, you'll find out what all your possibilities are. So the processor features to consider include the following. Use the highest performing processor that the board supports. That's always a good thing to do because later on it's more expensive if you want to buy another one and upgrade, as I mentioned before. Understand the processor's ability to multitask. Is it multi-threading? Does it support things like VMware? These are things to know about. Balance the performance and the power of the CPU with that of the entire system. That makes sense. More importantly, you need to balance the cost versus your performance. Look for that sweet spot. That's usually another important thing. Read reviews of the processors you are considering and look for reviews that include comparison benchmarks of several processors. There are great magazines out there that do that. There's also great resources online. Google University, just go to Google and you'll find what you need there. There's tons of reviews on different things. Look for things that are a little bit more honest. There's places you can go for things like Linus's tech reviews and things like that. There's plenty of great places you can check for reviews on different processors and stuff. And usually they get them when they just come out, so you can get a lot of great reviews and hints on what you should be doing or using there. When processors and coolers are boxed together, the cooler heatsink might have thermal compound already applied to the bottom. Thermal compound is like it's a paste that fills in the gaps between your cooler and the CPU itself. It just makes it connect better so that it dissipates the heat better. General procedure for installing an Intel processor includes the following steps. Use an ESD, which is the electrostatic dispensing. The electrostatic, I forget what the D is, but it's for getting rid of the electrostatic charge that you may carry. So you'll ground yourself on the chassis of the system, or you can wear anti-static gloves. When replacing a processor, power down your system, unplug the power cord, press the power button to drain the system of power. This should be pretty familiar to you by now. And then after all that, you open up the case. Then you'll want to remove this socket protective cover, push down on the socket lever and gently push away from the socket to lift the lever. As you lift that lever, the socket load plate is going to raise, and then you're going to remove the protective cover from the processor. Then you'll align the processor so the two notches on the edge of the processor line up with the posts embedded on the socket. In the old days, we had like a corner notch on it for the Intels that you could line up and just drop right in. Now it's a little bit different, but these are the steps for it. Then you're going to ensure that the process is aligned correctly in the socket. Then you're going to push down on that lever and gently return it to the locked position. Sounds like your airline. Remember to return to the upright and locked position. But that's how you go about changing out your processor. Here's a graphic example of that. So you want to align the processor in the socket. There's a gold triangle and right angle mark on it. So if you look at it where it says right angle mark, you can see that little notch that I mentioned before. So you line it up off of that. Then you just, the pins and the holes are going to align. Then you just put it on there. You shouldn't use any force to put it in there. If it's not going in, don't force it. That's going to bend your pins. You don't want that. So line it up, drop it in there. It should just snugly drop right down into it. Then you put your enclosure over it, and then your lever goes down. So the general steps to install the cooler assembly include the following. Understand how the cooler posts work. There's different types of coolers out there. Some of them have these posts at the end of it. Some of them actually just ride on the CPU directly. I think that's less done now because the CPUs are larger and there's heat dissipation issues. But what you'll do is you'll apply that thermal compound if necessary. Sometimes it's pre-applied. Make sure you know beforehand. So get that thermal compound on there. You don't need a lot, just a little, teardrop will do. And that, you get that put on the bottom, and that should help, because as that heats up, that thermal compound is it's gonna close those gaps between your CPU, the CPU and the heat sink. So some heavy coolers provide a plate that fits underneath the motherboard. After the plate is installed, install the cooler on top of the processor. For lighter coolers with locking pins, verify that the locking pins are turned counterclockwise as far as they'll go. Then you'll connect the power cord from the cooler fan to the motherboard. And there's going to be little headers on the motherboard for you to connect those cooler fans. There's usually plenty of them on there because people like to have a lot of fans connected to the motherboard. Then you're going to check the BIOS UEFI setup to verify that the system recognized the processor. That's important. Sometimes you may have little glitches, or sometimes you may get a bad CPU, and the BIOS UEFI setup is going to help you identify that. And over here, this is one of the header fans that you have on the motherboard. It's a 4-pin CPU fan head that you just connect it right on there. And you can see the elaborate posts that they have on the CPU in this picture too. So that is pretty neat. So that's a little bit heavy duty. So going back to what I said about putting together computers, I used to build them all the time. To be honest, in the last 5 to 10 years of my professional experience, it's made more sense for me to buy systems from Dell and HP because the price points were just too good and the customization wasn't necessary in a business environment, especially for coding and things like that. For personal, this is more important, I think, to know how to build these. If you are really wanting to make something that's cutting edge, knowing how to do this is very important. But and of course, if you're doing maintenance, this is very important. But if from a business perspective, as somebody that works more in the management side now, it really makes sense to buy systems from Dell and HP because they're standardized. And when you have standardized equipment, you don't have to keep sheets on 20 different types of computers that were all built with a little variation, for each one. So it's nice to have some standardization. But anyway, the point of what I was saying was I haven't seen a CPU like that on any of my systems yet, because this is pretty honking. This is really nice. So you got that big multi-layered CPU fan, and it has the connectors that go back down. But yeah, that's pretty elaborate right there. So installing a processor and cooler assembly, continuing on. So installing an AMD Ryzen or Athlon processor includes the following steps. You're going to open the socket lever and remove the protective cover. You're going to orient the 4 empty pin positions on the bottom with the 4 filled hole positions in the socket, and you're going to carefully place the processor in the socket. Notice that this is going to, I think we've got a graphic coming up, and you'll notice that there's a little bit of difference the way you align it than you did with the Intel processors. So you're going to verify the processor pins are sitting slightly into the holes. Then you're going to press the lever down and gently into position, apply thermal compound and install the cooler, like we talked about in the previous step, previous Intel one. And then you're going to clip the clipping mechanism into place on the other side of the cooler. You're going to connect the fan power cord to the 4-pin CPU fan header on the motherboard, just like we did previously. And this is what it looks like. So you've got 4 notches in here that you've got to line up with the socket. So you line those up and put those in, then you're going to be using your lever and everything. So yeah, just look for the 4 holes right there. So knowledge check, activity 3.1. What new parts will you need to replace a failing processor? So let's take a look at it. Power cable. Are you going to need a power cable? New parts here. Focus on the new parts. Are you going to need a new power cable? Most likely, I would say no. Processor, yeah, if you're replacing a processor, you're going to need a processor. Cooling assembly, you might. If you're not able to use the previous one, you might have to you get a new one because you don't know why the previous one failed. It could be because your previous cooling assembly failed. And thermal compound, again, that is, it's possible that you'll need that. It really just depends on whether or not your new processor comes with the thermal compound. So the 3 things that I would say, B, C, and D, you're going to need, but it depends if you can reuse your C from the previous one. It depends if D was there from, or if it's, comes already on. So I'm going to say B, C, D, but definitely B, and the C, D are optional. So B and D, so it says the new processor and fresh thermal compound are needed to replace. Power cable and cooling assembly can be reused. But again, as I said, the cooling assembly, if a faulty cooling assembly wasn't the cause of the failure to begin with. So that is, yeah, I can understand them not having C on there. The reason I kind of like C as well is I had a Dell that was about 5 to 10 years old, and I opened it up. It was my mother's actually, and it was failing, and it would turn off intermittently and at different times. So I opened it up, and it was full of dust. So I dusted it out, and I was amazed that after I dusted it out, and it was in the mainland, so they don't have the salt in there like we do here, so it doesn't rust on the inside. So I dusted it out. I took every component out, and I dusted everything, got it all shiny. I was amazed. It looked like it was brand spanking new. But there was one little problem, and that problem was the heatsink and the fan unit. They were on posts, and the post had cracked. The plastic had actually cracked. So I ended up thinking, gosh, I don't know if this is a problem or not, but I was having that intermittent fail going on. I checked my capacitors on the motherboard. You know, sometimes you'll see a capacitor that's burst open or something. Didn't have any of that. So I was like, I wonder if I've got a fan issue here. So I went ahead, looked on eBay. I found a replacement one that was close to what it needed. I replaced it for about 10 bucks, and I put it on there, got the thermal compound on there. I put the new the heatsink on it and fan, and voila, it ran just like a champ. And so it had been that failed, or what had happened was because one of the posts had broken, it wasn't seated on there, and because it wasn't seated on there perfectly, when the thing would run hot, when it would start to heat up the CPU, it would fail at some point, and it would just shut down automatically. So it just intermittent shutdowns like that. So replacing the fan was all that was necessary. I still have that computer. It's probably 15 years old, runs like a champ, wonderful. It's not going to be doing anything, really graphics, intensive, but I mean, it's a wonderful system, still works great. So yeah, so that's why I say that C there is a little bit on the iffy side. So now memory technologies. Random access memory temporarily holds data and instructions used for the CPU. Dynamic RAM, DRAM, loses its data rapidly, and the memory controller must refresh it several thousand times a second. So two major categories of memory include, so all current motherboards for desktop use DIMM, dual inline memory modules, and SODIMMs are used for laptops, and SODIMM stands for small outline DIMM. So those are used in laptops. So right here, you're looking at a motherboard with DIMMs on it. So you can see that you've got 4 slots for DIMMs. It says 1 populated black slot and 1 empty black slot, 2 empty blue slots. So often when you're putting in memory, you have to pair it. So you'll have to look at your motherboard to see it, how you need to actually put in your memory. Do you have to match them? And it's always good to match the same type of RAM. You don't really want to be mixing vendors in here or different speeds and things like that. So always try to keep your memory the same brand and same types if you can. It's okay to use different amount of memory if it's the same brand, same type, and everything else. But you have to mix them in a certain order. So use your manufacturer's go to the manufacturer's information for that. So DIMM and SODIMM technologies. The D in DIMM stands for dual, but independent pins on both sides of the edge connector. So DDR is double data rate DIMM. It runs twice as fast as the earlier DIMMs when it was invented. DDR3 uses 240 pins and are not compatible with other DIMM types. They have different notches on them. DDR4 is faster and uses less power than the DDR3, which is a big advantage. And it uses 288 pins and has a single notch in the edge connector. And you've got DDR5, it's faster, uses less power than DDR4s, offers up to 64 gigabytes of DRAM and uses 288 pins. So I personally have experience with everything up to DDR5, I believe. I haven't used DDR5 personally. And again, it's what I said before about, I've only had to build them up until about maybe, I guess the last one I built by hand was about 5 years ago. But yeah, I had only worked with up to DDR4, but yeah, you'll be seeing these, and the older ones and everything, you'll see them in museums. I actually have a box of old memory sitting around here and other parts as well that I just keep for memory keepsakes. So factors that affect the capacity, features, and performance of DIMMs include the following: the number of channels they use, how much RAM is in one DIMM, the speed, the error checking abilities, and the buffering. So you've got single, dual, triple, and quad channels. So single channel DIMMs mean the memory controllers access one DIMM at a time. The dual channel allows the memory controller to communicate with two DIMMs at the same time and doubles the speed of memory access. So the triple channel motherboards can access three DIMMs at once. And you see a pattern here. Quad channel motherboards can access four DIMMs at the same time. So DDR3, DDR4, and DDR5 DIMMs are dual channel. The DDR3 DIMMs can use triple channels. They can also use triple channels, but DDR3, 4, and 5 can use quad channels. So keep that in mind when you're buying these. And always go according to your motherboard specifications for what you need to use. So for dual, triple, and quad channels to work, the motherboard and the DIMM must support the technology. So like I said, make sure you read the manual as to what types of DIMMs are supported. So the motherboard manufacturers typically color code your DIMM slots to show you how to configure dual, triple, and quad channeling. Again, it's written into your manuals. Set up the dual channeling. Know that the pair of DIMMs and channel must be equally matched in size, speed, and features. As I was mentioning earlier, you don't want to be mixing that. And again, it says, just like I mentioned before, you want to make sure that you're using the same manufacturer, because you'll find that sometimes you have funky behavior when you start mixing vendors in there. So for a triple channel installation, 3 DIMM slots populated with 3 matching DDR3 DIMMs. And here, if you look at it, we've got the DIMM and the SO-DIMM technologies. It shows that using dual channels, the memory controller can read from 2 DIMMs at the same time. Here's how that looks. So take a good look. It shows your processor, the memory controller, and it shows the different slots there. So you can expect a motherboard that uses quad channeling to have 8 memory slots. The 8 DIMM slots support 4 channels. Each channel has 2 slots. The processor can address the 4 slots and 4 channels at the same time. To know which of the 8 slots to populate for optimum performance, again, you need to see the motherboard user manual. For a lot of this, you're going to need to reference the manual. And here is a beautiful graphic of the Gigabyte AMD X399 gaming motherboard. It's got 8 DIMM DDR4 slots, and it supports quad channeling here. That is a beauty. So DIMM speeds are measured in either megahertz or PC rating. A PC rating is a measure of the total bandwidth of data moving between the module and the CPU. So to calculate the CPU or the PC rating for the DDR4 DIMM, multiply the speed by 8 bytes, because a DIMM has an 8-byte or 64-bit data path. So for example, a DD4 DIMM that runs at 3000 megahertz has a bandwidth or transfer rate of 3000 times 8, and that gives you 24,000 megabytes per second, which is expressed as a PC rating of PC4, 24,000. So DD4 PC rating is labeled PC4. So error checking technology is called ECC, error correcting code. It's used for reliability. So DIMM that supports ECC will have an extra chip, the ECC chip. And also think error correcting codes, because this gives you that reliability, you're looking at extra cost as well. So ECC compares the bits written to the module to see what is later read from the module. It can detect and correct an error in a single bit of the byte. If there are errors in 2 bits of the byte, the ECC can detect the error, but it can't correct it. So with ECC, the data path width is 72 bits, with the extra 8 bits used for error checking. So buffers and registers hold data and amplify a signal before data is written to the module. They can increase the memory performance in servers. Some DIMMs use buffers such as registers, and some use neither. You might see registered memory written as RDIMM. So yeah. CAS, the column access strobe, latency is a way of measuring access timing. It refers to the number of clock cycles it takes to write or read a column or row of data off the memory module. So the memory module adds might give the CAS latency value within a series of timing numbers. Types of memories used in laptops. Today's laptops use DDR4, DDR3L, or the DDR3 SO-DIMM memory. You can only use the type of memory the laptop is designed to support. This should be a no-brainer. Again, look at your laptop's manual for information on what type of memory you can use. You can also go online when you're looking to upgrade. Sometimes I look to upgrade memory from a laptop, and I'll go ahead and I'll put in the specs, like the model number for the thing, and do memory upgrade. And you'll find places like Crucial and other places that sell memory. They'll have things designed for that specific system. You can often find memory cheaper than it is to go through the original equipment manufacturer. So keep that in mind. The number of pins and the position of the notches on a SO-DIMM keep you from inserting the wrong module in a memory slot. That's nice to have because God knows what would happen if you did misalign that. Virtual RAM or virtual memory is the way Windows uses space on the hard drive to enhance the amount of RAM in the system. Windows normally stores virtual memory in pagefile.sys. It's a hidden file that's stored in the root directory of drive C. If you have the ability to see hidden files, you'll often notice that, and it's quite a large file. So don't freak out, and please don't erase that. I think it's protected and you can't erase it, but yeah, never try to do that anyway. So not having enough free space on drive C can cause pagefile.sys to be too small, resulting in a low memory warning as well. So upgrading memory. This is one of the easier things in maintaining your computer. So to upgrade memory means to add more RAM to a computer. Sometimes you have to get rid of the old RAM because if you look at your configurations, if you want to max out your RAM, you're going to have to, let's say you had two 4 gig SIMs in there, or two 4 gig RAM modules in there, and you had 4 slots, and you wanted to get, let's say 32 or something. You're going to have to pull those 2 4s that you have and replace them all with the 8s. So yeah, so it may not just be adding to it; it may be replacing it altogether. So adding more RAM might solve the following problems: slow performance, applications refusing to load, an unstable system, Windows insufficient memory error message. So how much memory do I need and how much is currently installed? So when deciding how much memory the system can support, consider the limitations of the motherboard, the processor, and the operating system. So limitations when considering the operating system include Windows requires at least 1 gigabyte for a 32-bit installation and 2 gigabytes for a 64-bit installation. Normally, that's not a problem. Most systems now have quite a lot more than that, so it's not something to worry about. For 64-bit installations, Windows 10 Pro can support up to 2 terabytes of memory, not gigabytes, terabytes. That's a honking amount of memory right there. And I don't know anybody that can afford that anyway. So if we're looking at a 32-bit Windows 10, 8, or 7 installation, it can support no more than 4 gigabytes of memory. So read that again. A 32-bit Windows 10, 8, or 7 installation can support no more than 4 gigabytes of memory. So adding memory is not going to do you any good there. So, so if you're going to try to figure out what you've already got installed, open up the case. First of all, you can look in your operating system and see how much memory you've got in there. But if you're going to look and see specifically what types, open up the case, look at your memory slots. How many memory slots, or how many slots do you have is an important thing. You should know that from your documentation. And then how many of them are already filled. So you're going to review the module imprint. Fine. You're going to examine the motherboard for the imprinted manufacturer and model. That's a no-brainer. Then you're going to read the motherboard documentation to see if the board supports dual, triple, or quad channels. If you still have not identified the module type, you can take the motherboard and old memory modules to a good computer parts store for confirmation. You can find this often by looking it up online. So here's the label that has a lot of the information on it. So if you look at the DIMMs, you can see a lot of stuff on there, and you can Google a lot of this as well and find out specifically what it is, and you can see the specifications. So if you just take that and put it, pop it in online, you'll get a good bit of information on this. So you'll be able to find stuff to match it. So read your motherboard documentation to find out how much memory the motherboard can hold, because you do have a max that it'll support. Even if you can find a lot of memory modules that are a lot larger, it may not support it at all. And like we said previously, your OS limits the amount that you can use anyway. So DIMM modules can be installed as single modules, but they won't be as productive. To get the full benefit of DDR4 dual channel DIMMs, install matching DIMMs in each channel. For a motherboard using DDR3 triple channel DIMMs, use 3 matching DIMMs in the 3 blue slots. And if the 4th slot is populated, the board reverts to a single channeling. So here you've got the 3 blue and the 1 black. So it shows your 4 DDR3 slots on a motherboard, or actually the 4 DDR3 slots. So how do I select and purchase the right memory modules? Compromises might be necessary if the exact match is not available, but keep the following in mind when selecting your memory modules. Mixing unbuffered memory with buffered or registered memory will not work. As we said before, keep like with like. Match the memory module manufacturer if possible. Please do this. It will eliminate a lot of headaches if things start to go wonky later on. And if you're mixing memory speeds, all modules will perform at the slowest speed. Repeat, if mixing memory modules, all modules will perform at the slowest speed. And you'll see this with when we talk about I/O things. If you've got USB 2, or let's say a USB 3, and you plug it into a USB 2, you're running at the slower of the two. So it's any extra cost that you spend on that memory, it's gonna go, it's gonna match the slowest speed. So it does you no good to buy that more expensive memory if you're matching it with slower memory. So keep that in mind. That's why, again, it's best to keep them all the same. The only time I guess you'd want to do that is if you're buying new memory for it and you had to use your old memory, and it just so happened that the most expensive stuff was cheap and the difference was negligible, and there's like, why not? We'll just go ahead and buy it. So I guess that's an acceptable time, but to do it. But if it's that cheap, just buy matching modules and replace it all. Anyway, that's just me complaining. But you can also use a website to research your purchase. As I mentioned before, you can find a search utility that will match your memory modules to your motherboard. There's lots of tools out there. A lot of manufacturers of memory are more than happy to take your product information and figure out what they can sell you. So, do look for those tools out there. And you can do that whether we're talking about a PC or a Mac, because I have Macs mostly. And when I go to do something like this, I always look up, I always look for the cheapest things I can find. Crucial is one of the best ones that I've found personally, but there are other manufacturers as well. So feel free to use these different sites to find memory for your PC or your Macs. Then how do I install the new modules? This is the simplest thing. When installing new RAM modules, follow these precautions. Again, ESD strap, strap on ESD. Again, in Hawaii, it's not as critical, but it's still a good idea to do it anyway. Turn off your power, unplug your power. Yeah, this is sounding familiar, yeah. Unplug your power cord, press the power button, drain off the juice, and then remove your case cover. So you're gonna handle your memory modules with care, of course. You don't want to touch the edge connectors on the memory module or the memory slot. Don't stack them on top of each other, and look for the notches on the side or in the middle for correct orientation, because when you look at the slots, you're going to see that it has that little notch in it. You're going to look to line the notches up on your memory modules when you do that. And then to install it, you're going to pull out the support. So you've got these little plastic tabs on the side. You kind of pull them outwards. And then when you do that, it's going to pop the memory module up, and then you can just remove it like that. So you do that, you pull it up, use your notches on DIMM edge connector as a guide. Then you're going to insert. When you go to put it in, you're going to insert it looking straight down into it. And as you push it in, do it on this, push in with the side, the plastic connectors are going to, they're going to automatically go back up, because as you put it down, it forces it to come up, and they're going to latch into two little notches on the side of the memory. So when the computer powers up, it counts the memory present, make sure that comes up right. You can also enter the BIOS UEFI to verify that the memory is recognized. That's an important thing in case you have any kind of issues between the motherboard and the memory. And here is an example of what I was talking about. You take your fingers, you put them on the side, and as you put it, your fingers on the side and push down, equal force on both sides, those plastic connectors are going to pop up in the side, and the little latch is going to latch into a little notch on the side of the memory chip. So how to upgrade memory on a laptop? Don't throw it away. Just kidding. Before you're upgrading memory on a laptop, make sure that the warranty is not being voided. I don't know if this is really 100% valid anymore, because there's been a lot of lawsuits recently about whether the right to repair and things like that, and whether companies can void the warranty automatically. So this is something to look out for. Search for the best buy on a suitable and authorized part. That goes without saying. But if you're dealing with a laptop, you're going to need it specifically for that manufacturer. So keep that in mind. Again, online sites are going to be good for matching it up for you. They want to sell you the memory. They want to get you the best thing. So yeah, so use their sites like Crucial and others. Upgrading memory on a laptop is similar to upgrading memory on desktop. You got to decide how much memory to upgrade. You're going to have to buy it and you're going to have to install it. These are no-brainers. And be sure to match the type of memory to the type that the laptop supports. Again, if you've got the laptop model number, and sometimes you'll need to know the year it was produced, like if you're working with Apple stuff, you can find that. And again, those websites online will help you match up what you need. So now, knowledge check. Motherboard has 4 DIMM slots. 3 of the slots are gray and the 4th is black. What type of memory is this board designed to use? Is it for DDR4, DDR3, DDR5, or all the options listed? Well, the answer is DDR3. We had a picture of that earlier. DDR3 is the only option of DIMMs that can handle triple channels, which is indicated by the color of the memory slots. So that one we saw earlier with the image where we had the 3 of one color and then the 4th. So summary, now that the lesson is ended, you should be able to compare the characteristics and the features of processors used for personal computers. You can select, install, and upgrade a processor, compare the different kinds of physical memory and how they work, and upgrade your memory. Memory, again, is the easiest one. The main thing is that you need to make sure that you're using the right types of memory. You're always going to want to consult with documentation for your specific motherboard or manufacturer of laptop. And but installing is a breeze. Once you know how much memory you need in there and how much you have to pair up, once you do that, it's easy to install. The processor is a little bit more involved and a little bit more, delicate, I would say, because you're removing it, and then you're going to have to go and put on the thermal paste. Not too much, a little goes a long way. A little bit of thermal paste on the bottom, lining it up, putting it in, getting it all ready, and then hooking up your fan to the headers and everything. I think that's a little bit more involved, but the memory is a lot easier, but it takes a little bit more groundwork to make sure that you've got the right stuff. So anyway, that is the summary for this lesson. I hope you've learned a lot, or at least reviewed and solidified in your head a lot of this stuff. If you have any questions, as always, feel free to reach out and I'd be happy to help you with that. Now we'll go on to the next lesson. Enjoy.